Let's talk about applications of quadratics today. Your notes might look slightly different from mine, but all of the content should be exactly the same, so just follow along and fill in your notes. I want to first point out this vertical motion model. So as you can see, this obviously looks like a quadratic function, and I can tell it's quadratic because the highest exponent is a 2. So I know that this is a quadratic function. In this particular model, h, let me see if I can do this, h represents the ending height. I'm going to change some colors here. T represents time in seconds. That's pretty easy. Time. T, time. V is velocity, and remember the velocity is the speed of something in a given direction. And then S represents the starting point. So we're going to use this formula as we go through these problems. So one of the big questions I get is what point should I find on the graph? So here's an example of a quadratic graphed on a coordinate plane. Most of the time you will see height versus time, but you always want to make sure that you know what everything represents. Okay, so if I know in my word problem that height represents the y values and time represents the x values, I like to draw or write an ordered pair and label my x values are going to represent time and my y values are going to represent height. So I can just reference that throughout my problem solving process. So there's a couple of key points that I've got on here that I want to label. And you have these notes, so you can label on your notes as well. So this up here, if you're asked to find the maximum height, okay, of a golf ball, so the next example is going to be a golf ball, so I have golf ball on here. The maximum height of a golf ball after X seconds, you are looking for the vertex, okay? You're going to be looking for the vertex. Keyword is maximum, okay? So we're going to be finding the vertex when we see something like that in our word problem. And then I just have an ordered pair written here. It says, at what time X did the object reach a height of Y? 10 feet. So that's just a random point on the graph. So if you're asked something like that, like at what time did it reach a height of 10 feet, you're just looking for a point on the graph. What is x when y is this? What is y when x is this? And then, as you can see, I have an arrow pointed to this solution right here, this x-intercept. And in this case, it says at what time x will the ball hit the ground? So at what time will the height be 0? We're looking for an x-intercept here. So we can refer to this as we solve some of these problems. So let's look at the first problem. It says a golf ball is hit from the ground with an initial velocity of 100 feet per second. The equation h equals negative 16t squared plus 100t gives the height of the ball after t seconds. What is the maximum height of the ball? So maximum height is y. I'm looking for a y value. What is the maximum height of the ball? What am I looking for? I'm looking for the vertex. Okay, so how do we find our vertex? Well, I know that the x value of my vertex is negative b over 2a. And then the y value of my vertex is going to be whatever the y value is when I plug in that x value. Okay, so let's do that. So in this particular case, a is negative 16 and b is 100. So I'm going to plug in negative b over 2a. So negative 100, I'm going to come over here, over 2 times negative 16. And I've already got that figured out. You can use your calculator, or if you have a teacher that does not want you to use your calculator, you can actually do the arithmetic. It's 3.125. So when I plug in 3.125 in for x into my equation, I get h equals, negative 16 times 3.125 squared plus 100 times 3.125. And I'm just plugging this value in for x, or in for t, and I get 156 0.25, and I know that that's my answer right here because I'm looking for the maximum height. So my x value is 3.125, my y value is 156.25. It's asking me for the maximum height, so there it is. All right, let's go on to number 2. At what time will the ball reach its maximum height? Okay, well, I'm still looking at maximum height. I still know that's the vertex, but it's asking me at what time. Well, time, we're looking for the x value. Well, we've already figured that out. It's 3.125 seconds. Awesome. And how long, that's time. How long will it take for the ball to reach the ground? Okay, so when it reaches the ground, my height will be 0. How long? We're looking for an x value. How long will it take for the ball to reach the ground? We're looking for a root or a solution or an x-intercept. So in this particular problem, I am not going to factor it. I'm going to use the quadratic formula. Okay, so I know that A is negative 16, and B is 100, and C is 0. And I'm going to plug these values into my quadratic formula. Now, y'all know, if you've seen any previous videos of mine, I sing the quadratic formula as I'm plugging in values. So, x equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. All right. And now I have obviously already done this problem, and I've used my calculator to simplify some of this. So x equals negative 100 plus or minus 100 squared minus 0. And if I take the square root of that, I'm just going to get 100. Okay? Over negative 32. So I know that my solutions are going to be negative 100 plus 100 over negative 32. And what do I get there? I get x equals 0. Okay, negative 100 minus 100 divided by negative 32, I get 6.25. Okay, so these are my solutions. So which one will I use? Well, I know that this particular 0 is the starting point. So obviously the 6.25 is my answer. So how long will it take for the ball to reach the ground? 6.25 seconds. Boy, that's a long time for that golf ball to be in the air. All right, let's go to our next example. And if that confused you, hopefully the next examples will help. Okay, at the last 4th of July celebration, Caleb fired fireworks vertically into the air at an initial velocity of 75 feet per second. The equation for the height h of the firework after t seconds can be modeled by h of t equals negative 16t squared plus 75t. Okay, at what time will the firework reach its maximum height? So at what time, we're looking for an x value, will the firework reach its maximum height? That is our vertex. We're looking for our vertex, but we're looking for the x value or the y value? We're looking for the x value. So I know that the x value at my vertex is negative b over 2a. So let's label a is negative 16 and b is 75. Okay, so now if I plug in negative b over 2a, I'm going to get negative 75 over 2 times negative 16. And when I plug that into my calculator, I get 2.34375. And I'm going to round that to the nearest hundredths place, and I get 2.34 seconds. So this lesson is all about determining what you need to find. Okay, so if you're struggling finding any one of these things with a formula or anything like that, go back to a previous lesson, either solving using the quadratic formula or even the intro to quadratics, which deals with the axis of symmetry and the vertex. And so hopefully that'll explain some of this math that I'm doing in the middle. So number 5, At what time was the firework 20 feet above the ground? Okay, at what time, that's x, 20 feet, well, that's going to be y, or I guess I shouldn't say x, I should call it t. This is height. Maybe I should do that instead of x. Call this, is it going to let me erase it? Call it t. Okay, at what time? At this point, we're just looking for a random point, okay? What is t when h is 20? Well, let's just plug in 20 for h and see what it looks like. So I'm going to, instead of h of t, I'm going to plug in 20 equals, and I'm going to write everything else down. Okay, and now how do I solve this quadratic? Well, again, if you go back to a previous lesson, you need to put this in standard form. How do I do that? I subtract 20 from both sides and set it equal to 0. And now I'm solving. And we've done different ways to solve. We've solved by factoring. We've solved using the square root method. We've solved using the quadratic formula. And you may even know how to solve using your calculator. I'm going to use the quadratic formula for this one. So this is negative 16 is A, 75 is B, negative 20 is C. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if you need to pause and maybe, pause the video and do some of this on your calculator, go ahead and do that. I've obviously already done that, so I'm going to write that down. I end up getting negative 75 plus or minus the square root of, when I find that discriminant underneath my square root, I get 4,345 over 2 times negative 16 is negative 32. And when I plug in negative 75 plus the square root of 4,345 divided by negative 32, and then negative 75 minus the square root of 4,345 divided by negative 32, my solutions are 0.28 and 4.4. Wait a second, I've got two answers. Well, wouldn't that make sense? If a firework comes up and then it goes down, it will be at the height of 20 feet at two separate times. At 0.28 seconds, or of the point, or 2800th of a second, and 4.4 seconds. I've got two answers for this particular problem, and that makes sense. If that firework goes up and then it comes down, height versus time is going to look like, and I'm going to go back to my model, the height versus time is going to look like this. It's going to start here, and a lot of students want to say, oh wait, well here's the distance. This is the distance that has traveled. No, it traveled vertically into the air, but time is moving. So as time continues, that firework goes up, and then it reaches its highest point, and then it comes down. So it will be at that height. Let's just say this is a height of 20. It'll be there 2 times. Okay, so that's what we're looking for. Okay, let's go to the next one. How long will it take for the firework to reach the ground? How long, that's x, will it take for the firework to reach the ground? That's when h is 0. I did it again. That should be a t. Okay, so what are we looking for? We're looking for a 0 or a root or a solution. So in this case, I'm going to plug in 0 for h. And again, I'm going to solve using the quadratic formula. A is negative 16, B is 75, C is 0, and I'm going to plug it in, okay? X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. It's catchy, isn't it? Yeah, I learned it in high school, and I sing it every time I teach it. Okay, so now I end up getting, and obviously if you want to pause the video, solve it yourself, go ahead and do that. But the first thing I always do is simplify, find this discriminant, and in this case, I get negative 75 plus or minus 75 divided by negative 32. Okay, and my solutions end up being 0 and 4.69. But I'm looking for how long will it take for the fireworks to reach the ground. I know 0 is my starting, so my answer is 4.69 seconds. Okay. And, you know, at some point I do teach my students how to solve this on the calculator. I'm not going to do that on this lesson because there are so many different calculators out there that students use. So there are ways to, especially if it's like an end of course exam, there are ways to solve this on a calculator. So that helps. But a lot of times on tests, you got to show your work. So let's do one more example. I'll try to move fast through this. A baseball is thrown from the stands onto the field that is 20 feet below. The ball's height above the ground is modeled by h of t equals negative 16t squared plus 28t plus 20. What is the maximum height of the baseball? Maximum height. I'm looking for a y value, right? Because that's height. Again, you can label. All right, here's what it gives me. Height above the ground is modeled by, okay, this right here. So there's the height. And I know t is time. Oh, I did it again. I just can't move away from the x and the y. But there we go. We're looking for a y value. The maximum height of the ball. I'm looking for the vertex. So the first thing I need to do is find the x value of my vertex. How do I do that? Negative b over 2a. So negative 16 is a, b is 28, c is 20. Negative b over 2a is negative 28 over 2 times negative 16. And I get 0.875. How did I do that so quick? Because I've already taken these notes and I've already plugged it into my calculator. So now I'm looking for, because I'm looking for the y value, I'm going to plug in that x value into my equation to find what is the y value when x is 0.875. So when I plug it in, and you know, I like to do this, replace t with parentheses, right? T with parentheses, and then what you're replacing, you put inside the parentheses. So I'm replacing t with 0.875, so I can replace it with parentheses first, then I put the number in there. And so when I plug this into my calculator, I get 32.25 feet. So some students I find really just need practice plugging these numbers into the calculator correctly. So I encourage you, if you're one of those students, pause this video when I say and plug it into the calculator exactly as you see it. Okay, number 8, we're almost done. 2 more examples, or 2 more questions. After how many seconds, all right, that's t. In this case, I'm going to say x. How many seconds will the ball reach the ground? After how many seconds will the ball reach the ground? Okay, that's when h is 0 or when y is 0. So I'm looking for a 0 or a root or a solution or an x-intercept. Okay, so after how many seconds will the ball reach the ground? I need to plug in 0 for h. And I'm going to use the quadratic formula to solve. All right, here we go. And we're going to sing it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I have obviously already done all of this. But if you want to pause this video and find your discriminant, what goes underneath the square root, you can do that now. You should get negative 28 plus or minus the square root of 2064 divided by negative 32. So you can enter it in negative 28 plus the square root of 2064. That's what I usually do, and then I press enter. Then I divide by negative 32. Or negative 28 minus the square root of 2064. Enter, divided by negative 32. And you end up getting two different values. The one that you should use is 2.29 seconds. Okay. And this is Algebra 1. I do realize in Algebra 2, a lot of these types of problems, you need to use simplified square roots. And I definitely have done that in my Algebra 2 classes, but this is the Algebra 1 method, and so we're going to use our calculator to do this for at least the word problems. So we do have to simplify square roots in Algebra 1. It's just what the question is asking. Last question, what will the height of the ball be after 1.5 seconds? Okay, let's change. The height of the ball, that's y, so I'm looking for y, will be after 1.5 seconds. Well, that's time, okay? So I'm just looking for a random point here, and I'm looking for the y value when t is 1.5. So h of 1.5, what is y when t is 1.5? I'm going to plug it in. Let's make this so I can see my equation. Negative 16 times 1.5 squared plus 28 times 1.5 plus 20. And again, if you just need to pause the video, enter it into your calculator, what do you get? 26 feet. Okay, because it's height, we have units. Okay, and that's feet. And that concludes this lesson over application of quadratics.